mother's got humor. She's the giggle at a funeral. Knows everybody's disapproval. I should have worshipped her sooner. If the heavens ever did speak, she's the last true mouthpiece.
Here we are at our last true lesson for trigonometry, Cartesian trig, reciprocal trig ratios. As I mentioned in the last lesson, the next lesson, so this is the last lesson that you're going to have assessed questions on. The next lesson is optional. If you're planning on taking grade 12 advanced functions, you should definitely watch it. You should definitely try some of the questions at some point. That way, when, assuming we are back to normal in class next year, when you take advanced functions, you're not seeing the material for the first time, especially when it gets much more complicated. If you're not taking advanced functions, it's still up to you. I still would encourage you to at least look at it, but you won't be assessed on it. And it's not going to help you if you're taking data management. And again, the reason being is that just the way trig identities are, which is your optional kind of mandatory but optional lesson, anyone can type an identity into Google and it will give you step-by-step instructions. And there's really no way for me to safeguard where you got your answer from. So it's pointless for me to assess it. But if you do have questions on it, by all means, I'm here to help you for those that happen to take a look. Our learning goals for this, we're going to learn about the reciprocal trig ratios. Reciprocal, again, just means 1 over. So let's start with some definitions, formulas, if you will. So the reciprocals of the primary trig ratio. So the primary trig ratios, of course, are sine x, which equals opposite over hypotenuse, or if you're someone buying into the secx or tix theme, then y over r. Now the reciprocal of sine x is actually cosecant, is how you say it, which is csc. And reciprocal again means 1 over, so cosecant x equals 1 over sine x. So there's your first kind of definition slash formula. And if sine x is opposite over hypotenuse, then cosecant x is hypotenuse over opposite, or r over y. Our next primary trig ratio is cos x, which we know is adjacent over hypotenuse, or x over r. The reciprocal trig ratio that goes with cosecant is secant, which is sec and then x, some angle, and secant x equals 1 over cos x. There's your next little formula. And if cos x is adjacent over hypotenuse, then secant x is hypotenuse over adjacent, or r over x. And our last primary trig ratio, tan x, opposite over adjacent, or y over x. The reciprocal of tan x is cotangent x, so cotangent, and its short form is cot x, and cotangent x equals 1 over tan x. And there's your third and final little formula, and cotangent x obviously then equals adjacent over opposite, or x over y. So for the rest of this lesson, we're going to be working with not only our primary trig ratios, but cosecants, secants, and cotangents. Our first example, find the exact value of the 6 trig ratios. The first thing you are going to want to do, again, we have root 325. That is not a nice number, it's a decimal, but we can break up 325 into 25 and 13. 25 times 13, 325. 25 has a nice square root, 5. So I just verbally kind of went over how to simplify that. That becomes 5 root 13. Make sure if this was a test question, you actually show that work and you just don't go to 5 root 13. So we're going to do sine theta, cos theta, tan theta, and then the reciprocals. Sine theta, so remember this is opposite, adjacent, hypotenuse. So sine theta is 15 over 5 root 13. Now that simplifies to, right, 5 goes into 15 3 times, so 3 over root 13. I got to get rid of that root in the denominator, 3 root 13 over 13. While we're here, we might as well do cosecant theta, which is just that flipped. So you can think of it in terms of hypotenuse over opposite, or you can just flip it. And when you're flipping it, I would flip it so you can avoid doing the radical work. I would flip it at this step. If you flip it at your final answer, that's going to put a root 13 back in the denominator. You're just going to have to do that step over again. So if I flip that, it's going to be root 13 over 3. If you don't like thinking about it in terms of like flipping or making the reciprocal, you could just do hypotenuse over opposite. The next one we're going to get to is cos theta. Adjacent over hypotenuse, so 10 over 5 root 13, and 5 goes into 10 twice, so 2 over root 13. Get rid of that. That leaves us with 2 root 13 over 13. And then the reciprocal, secant, would be root 13 over 2. And again, all I did was flip that. And the last one, tan theta, opposite over adjacent, 15 over 10. That one reduces quite nicely, 3 over 2. Cotangent theta, just the flip of that, the reciprocal, 2 over 3. There is the exact value of our 6 trig ratios. Example number 2, determine the following to 3 decimal places. There is no cosecant button on your calculator. There's no cotangent button on your calculator. So that means we have to relate these back to sine, cos, and tan. Well, we just learned cosecant x is 1 over sine x. So this, quite simply, is just 1 over sine 20. Type that in your calculator just like that. 1 divided by sine 20. 3 decimal places, 2.9238. So if we round to 3 decimal places, 2.924. Same thing for cotangent. That's just 1 over tan. So 1 over tan 20. Type that in, 1 divided by tan 20. 3 decimal places, 2.747. And that's it. Not too bad, right? Number 3, there's a little bit extra here. Instead of just determining the ratio, we're going to determine the following angles. And again, you can't just do secant inverse because you don't have a secant button. So the first thing you have to do, secant is 1 over cos x. So we're going to write that as 1 over cos x equals 1.7434. cross multiply because we want to get cos x by itself, right? Now I got to get rid of that 1.7434. So divide both sides by that. And if I want to find an angle, you got to use the inverse or shift button, right? So cos inverse of 1 over 7.34 equals x. Type it into your calculator just like you see it. Shift your second function, cos, open bracket, 1 divided by 1.7434 equals, I didn't say how many decimal places. We'll go to the nearest whole number. This will be 55 degrees either way. Another way you can think about solving this, if you want to cut out one of those steps, is once you're at this point, I got to get cos x to the top. I can't solve it if it's in the denominator. So a mathematical operation you could do is to flip it. And whatever you do to one side, you have to do to the other side. Really, this is the equivalent of raising both sides to the exponent -1. So I guess I could write that. But it just amounts to you flipping it. So that would become cos x over 1, right? And then 1 over 1.7434. Which that's what we got eventually in our second step. But again, that's just another way you can jump from the first line down to your third line. Our next one, cosecant. Cosecant goes with sine, so 1 over sine x equals 1.0353. You can go through all the steps like I did in the first part of A, or just flip both sides. That becomes sine x, and that becomes 1 over 1.0353. X equals the sine inverse of all that. Type that into your calculator just like you see it, and we will go to the nearest whole number. 1 divided by 1.0353. I get 75 degrees. Hopefully that's what you get too. If you do, virtual high five. Number 4, if cosecant theta equals 12 over 7 and theta is in quadrant 1, find the exact value of the other 5 trig ratios. Okay. So we're back to doing cast and bow tie Cartesian trig stuff. Draw an x and y axis. It tells you it's quadrant 1. That's right there. Cast it. We drew our triangle already. There's theta. Now you have two ways to think about this. You can think of cosecant as hypotenuse over opposite if you want to, which would make that 12 over 7. If that is confusing for you to think about it like that, then you know that sine is just the flip of cosecant. So really, if you wanted to, you could say sine theta equals 7 over 12, the flip of that. And now it's opposite over hypotenuse, which is the exact same thing. So we're missing one of the side lengths. We got to do some Pythagorean theorem first. You were given the hypotenuse, so this is 12 squared minus 7 squared equals x squared. 144 minus 49 is 95. Square root both sides. Just ends up being root 95. Remember, it says exact value, so we don't want decimals. You could try to break up root 95. I don't think it breaks up nicely, so we're going to leave it like that. So that is root 95. So we want the exact value of the other 5. So I mean, I've already done sine theta. It's just the flip, 7 over 12. Cos theta is adjacent over hypotenuse, so root 95 over 12. Tan theta, opposite over adjacent, 7 over root 95. Get rid of that root 95. In the denominator, 7 root 95 over 95. So that's 3. We need the other 2 to get to 5. I'm not going to bother doing cosecant. We already know what it is. Secant theta would just be that flipped, which would be 12 over root 95. Get rid of that root 95. 12 root 95 over 95. And cotangent theta would be root 95 over 7. So I'm going to flip this one, so that way I don't have to deal with the radical in the denominator again. So cotangent theta, root 95 over 7. Hopefully, again, not too bad. Number 5, this is our last example. Determine the exact values of the 6 trig ratios for 240 degrees. So this builds into today's stuff plus a couple of the last lessons. So this is a good question. X and Y axis, cast it, 240, where's that? That's all the way around here, quadrant 3, bow tie it. All right, so we need the related acute angle, right? How do I get that? Well, I could do 240. Remember that straight line's 180 equals 60. Whoa, 60. Hopefully there's some alarm bells going off, some happy memories. 60 goes with one of your special triangles, so 60, 30, 90. Label your sides, 2, 1, root 3. And we can now come up with the 6 trig ratios for 240 without using our calculator. So sine 240, now based off the quadrant it's in, we know it's going to be negative. Sine is opposite over hypotenuse, so negative root 3 over 2. While I'm here, I might as well do the reciprocal. Cosecant theta would then be that flipped, negative 2 over root 3. Got to get rid of that root. That would be negative 2 root 3 over 3. And remember, just like last lesson, you can always double check your answers. You could type in sine 240. It should be the exact same number when you type in negative root 3 over 2. Remember though, as I've been stressing, you have to show your work like I have in front of you so you can prove to me that you're just not using your calculator or a different resource that you have at your fingertips and you are showing me that you know what you're doing. Cos 240, adjacent over hypotenuse, 1/2, and in the quadrant it's in, only tan is positive, so that's negative 1/2. This is a nice easy one. Secant 240, oh, I just realized I wrote cosecant theta. We'll change that to 240. Secant 240, just that flipped, negative 2. Technically negative 2 over 1, but that's just negative 2, right? Tan 240, that would be opposite over adjacent, root 3 over 1, which is just root 3. It's in the tan quadrant, so it's positive. Cotangent 240 would be that flipped, 1 over root 3. Can't have that in the denominator, root 3 over 3. So there you have it. Again, hopefully that's not too bad. This lesson definitely short in comparison to your last two, and as I mentioned at the beginning, this is your last lesson that will have any assessed work on your test. The lesson after that is just a bonus. And again, if you're planning on taking advanced functions, you should definitely watch it at some point and try some questions at some point. And you can definitely ask me for feedback. That's it. Thanks for listening. Talk soon.